This conference will now be recorded.
Okay, so good morning and welcome back to the session. And today we are going to discuss about Redshift, Amazon Redshift. So in yesterday's session, what we have seen the difference between database, data warehouse, data lake, delta lake, and lake house. And we have gone through with all of those particular components. And what we have observed, delta lake and lake house, these are the emerging architectures wherever database, data warehouse, and data lake, these are uh, like old concepts, and we are having like a lot of tools or mechanisms where we can store, or with the help of that we will be able to process our data. Okay, now, Redshift, that is the data warehouse only, cloud-based data warehouse only, and it is having a lot of benefits if we compare it with the other tools available inside the market. Then it is very much better, and it is able to process the data or store the data with least amount of latency, and it is able to query, or you will be able to query petabyte of the data. And what we used to say, as per the official definition, it is fully managed services from the cloud, and that is petabyte scale, and scalability will not be a challenge over here. We just need to have a few clicks, and we will be able to have the environment, and we will be able to scale up the sources, resources. So let me start creating the cluster. Yesterday, what we have seen, we have created a cluster. Let me start from that particular step only, and then we will move further. This is the AWS console, what you are able to see, and over here I'm having S3. Let me go into the services, and inside the services, what we are able to see, Amazon Redshift. I have clicked onto the Amazon Redshift, and it will direct me to the Redshift. What I have described in our previous session. This is of two. We can go with serverless, and we can go with we can go, or we can have our customized solution, or we can configure this particular solution service as well. So we can create a cluster. So let me create the cluster, and we are going with certain details. We just need to mention certain configurations related things, like say I just need to mention the cluster name. You just mention a identifier over here, say booster analytics. First character must be in the lowercase. Booster analytics. Okay, alphabet or lower hyphen. It is not taking this particular identifier. Booster and it is not taking capital letters. Okay, so this is an identifier. I can give any name over here. And in our previous session, what we have seen, you just need to choose the node type. Now, what is happening? Redshift resources or Redshift nodes are of two types, or the cluster can be of two types: dense compute or dense storage. So, based upon those particular aspects, we are having two type sources over here. We are having two categories: RA3, that is recommended, and DC2. These are the two sources. and like RA, that is dense storage type resources we are having over here, managed storage up to 4 TB. So dense storage and dense compute, these two types of sources available once we are going to create the Redshift cluster. Let me pick like we are not having the heavy load. Once you are working onto the production environment, then you need to choose the heavy machines. So we are moving with the list number of configuration, list amount of configurations, and I'm moving with one node only. Yeah. With respect to the selection, what I have selected over here, so it is going to share the projected cost, like this is the total storage that I will get if I'm choosing DC2 large resource, and it will be the cost for the month. If this particular cluster is running for a month, then this is the cost which I need to bear. Okay, moving further, like if you want to load the sample data, today what we are going to do, we are going to read the data from S3. If you want to load the data, sample data, then that particular data will be available locally inside the cluster, and you there's no need to load it from the S3, but we will try to learn how to load it from S3. So we are not going to check it. Now, then admin password, if you are going to provide the password, then you can provide, and it will be managed by the AWS Secret Manager, or you can generate your own password or manually add admin password. So let me manually add the admin password, and I'm going to add a password over here. And let me show Boost Analytics one. So this is the password what I have configured over here. Now IAM role. So yesterday what I have mentioned, like we just need to define a role over here. I'm going to associate, this is the role which I have already created, and let me show what is in this particular role as well. I'm going to open it in new tab. So you just need to define a role and then create the cluster. Okay. Meanwhile, let me show what is available in this particular role. So once you are going to, if you are not having a role for Redshift, then what you need to do, you just need to create a role. So inside the roles, okay, you just create a new role, create role, and AWS service, and then give the service name, say Redshift. Okay, and you just need to select that particular service. Okay, and create. Okay, so it is going to create a role for you. This is the way, like in order to create a role. But what you need to do, you need to attach certain policies. Onto that add permission. So what you need to do onto that particular role what you have created, so you just need to attach certain permissions. So which permission you need to have, you need to have S3 access, because your service, this Redshift service, is going to communicate with S3, so you need to add permission for S3. Okay, let me show you the permission which I have added in this particular role. So there are two permissions only. So those permission you need to add, and inside the properties we will be able to see Redshift uh, IAM role. Okay, this is the big data factory Redshift. Okay, and just have a look onto the properties which have been added over here. Okay, so these are the two policies or properties, S3 full access and glue access. If you want to access glue as well, so you just need to provide the glue full access. So that, or if you want to provide the read only access, you are not going to write over there, then read only access you can add inside the property. just have a look how you will be able to add, say, you just need to click on add permission, attach policies, and if I'm clicking on S3, okay, it is providing me the details with respect to S3. Uh, S3 read only access. If you are just reading the data from S3, just click on to this particular policy. It is going to read the data. You will be able to read the data. The cluster will be able to read the data from S3 location. It will not be able to write over there. So based upon the property or policy that you are going to add, you just need to select. And for me, I have added two policies: glue full access and S3 full access. So that you need to create, and then you need to attach that particular policy or IAM role to the cluster, and the cluster will have that, and it will be utilized in order to communicate with S3 and glue. So IAM role is nothing but this is a mechanism in order to communicate with different services inside the AWS cluster. Okay, that is fine. Now we have the cluster is available. It is up and running. A Boost Analytics one. We have created this particular cluster, and this is up and running. Okay, so what we are able to see over here, the cluster is up and running. Now there are certain stuff. Certain tabs are available over here. Cloud performance, what I have mentioned, with respect to this, like how the cluster is behaving, CPU utilization, percentage disk space used, and auto vacuum space freed, the database connection. So these particular things are nothing but a view or the different stuff which are available inside this, but or the the visualization of this particular cluster, like the health status, query duration, and all. Then the next step is query monitoring. Over here, like it is showing me the query runtime for in this particular cluster, how many queries, what is the query runtime, and all, what are the matrices. So once we are going to run the queries onto this cluster, we will be having stats over here. Database performance, workload, concurrency. So these are nothing but once we are going to do the execution uh, of certain queries onto top of this particular cluster, we will be having the stats. Uh, Same stuff what we have seen in EMR. Like in EMR, what is the, if certain queries are being executed, then what is the peak of memory, what is how many core utilizations are there. So with respect to that only, we are able to get the information. Say last time range, say what is the performance of cluster from last 1 hour. Then zero ETL integration. So if you are going to integrate it with another tools and all, so integration ID, status, those particular things will be available over here. So it can be integrated, this Redshift can be integrated. I will provide you certain guidance how you will be able uh, to provide these particular details, and with the help of Python or PySpark code only, you will be able to communicate with this particular cluster. So we can connect the Redshift cluster with certain tools. If like you want to connect Redshift, and you want to perform the addition of a database, or you want to query from a particular database like MySQL or SQL connectivity with Redshift, that is quite possible. With the help of these particular connectors, you will be able to connect with Redshift. Then resource policies. So these are certain policies which are available, and you can add users, or you can provide certain integrations, authorizations, and all. You can add users and all. So this is with respect to how you are going to utilize this particular cluster. Authorized principals and add authorized principals, so those persons will be able to use this particular cluster. Then schedule. uh, so if like you are going to execute certain queries, and you can schedule those particular things over here. Okay, so that is quite possible over here. Then maintenance with respect to the cluster, like say uh, certain details will be available with respect to the performance of this particular cluster, like these are the maintenance detail. Uh, when the periodically maintenance will happen, you can get the details onto this particular url. Okay, and then if maintenance is something like if certain upgrades are there, allow version upgrade. If you are going to upgrade it, try to think in this particular way. This is a cluster of this is a what we have configured, that is a cluster of different machines, and our services are running onto this particular cluster. Now if we are having certain applications updates and all, how it will happen? It will happen automatically, yeah. Okay, release status update up to data. If we are having upper release available, then it will show like we are having this particular update available. You just need to install it. Maintenance track current, and maintenance window every Wednesday. This is the maintenance window. Once on this particular maintenance window, things like say upgrade, version upgrade, release status, those particular things will be done. Okay, so these are the backup details. If you want to take the snapshot of the cluster, if you want to take the backup, so these particular things will be happening. So that is nothing but maintenance related stuff. The main stuff, that is nothing but the properties which we are going to use over here. What we are able to see: dev, port, and admin user. Certain, like if you want to have the SS SSH session integration, then you need to utilize this particular key and all. The network and security settings, so VPC and all, availability zone, and the VPC security group, these particular things are there. At the end, what we are having IAM role, and this is the IAM role what we have attached onto this particular cluster. These are specific details. We need to use this particular property, yeah, database configuration. So let me open a new tab. Okay, so Redshift, and once we are going to click onto the this particular cluster, and I'm going to use the query editor in order to query. So query editor, it is asking me connect to the database. So let me click onto the connect database, and it is asking certain credentials. So cluster name, what is the cluster name? Booster Analytics. I am moving with these particular default configurations, like your current, create a new connection, temporary credentials, and all. I have not stored the credentials inside the secret manager, so it is use temporary credentials for the authentication perspective. Okay, now these are the details, the database and the database user. From where I can get these particular details? Inside the properties only. Yeah. So in properties tab, we will be, or section, we will be getting these particular details. And database name is dev, and admin username is admin AWS user. That's what I'm going to fill over here, dev, and username is admin user, and I'm going to click on connect. Now just have a look. It is showing me connected. I'm connected with database. Okay, so now I'm connected over here, and now I will be able to write down the queries. So, what I mentioned, we are going to use these particular tables. I'm going to create certain tables, and these are the tables. These are the simple SQL command create tables, and based upon the data, like we are having these particular fields. Let me show you the provide you the flavor of the data which is available. So, mhm, complete structure. Hmm. So we are talking about the users table. Over you will be having all users pipe. This is the table all users pipe. And in this particular table, what we are having this particular schema. So this table is having say user ID that is of integer type. User ID. Okay, this one is the user ID. Okay, then first name, the username, first name, last name. This is the username, first name, last name. So based upon the data which is available in this particular file, we are having the structure of this particular table. We are just going to copy this particular table and paste it inside the editor. So let me copy. This is simple command, simple SQL command, and let me create this. Okay, so it has created this particular table. So the table has been created and it is showing me the success. Now in the same fashion, what I can do, I can create the rest of the tables. Okay, copy, and I can paste this particular command over here. Okay, then just have a look over here. We are having the users table. In the same way, the venue table is created. Now, what I'm going to do, I'm going to create the rest of the tables. Say category table is here. I have picked the command create table category and cat id small integer cat group varchar cat name varchar and cat desc. Okay, category descending order. So that is like that will be a column in this particular category table. So that is also created. Okay, you soon you will be able to see that particular table over here, category table, no? So query it is showing certain error. Let me. Okay, so category table has been created. Now, say date table. In the same fashion, I will be able to have the date table. So I think the short key is not. It is not taking short key. Okay, so date table is also created, and event. Let me create the event table. Okay, these particular tables, I'm just like copying and pasting that particular structure over here. And if you want, you will be able to get like the column names over here. You will be able to preview the data, but data is not available, so nothing will be visible over here. So preview, that is nothing but select star from the table command. No? So preview, so nothing is available. Show schema, you will be able to see the schema of this particular table. Say cat ID, cat group. the type is integer, null, true, length is this, okay, precision 5 and all. So what we are able to see, we are able to create the tables. We have created users table, venue table, event table, date table, and category table. These particular tables we have created. If you want, like, we can create all of the tables, but I just want to give you a flavor. Okay, so these particular tables have been created, and what is the next step? Like, just have a look over here. Like, we have created the cluster, we have configured the rules and all. Okay, so we have defined the the details while creating the cluster, then grant access. We have provided the username and password, okay, details. Then we have connected with the database, and now we are creating the tables. So tables have been created. The next step, what is the next step? We just need to load the data inside this particular table. So okay, let me try to copy this. Creation of table. Okay, so with the help of this, we are able to create the table. Now load the data. How to load the data? Just have a look. Load the data. Okay, what is happening over here? This is the syntax. Copy users from. Okay, so users is nothing but the table that we have created. Users is the table. Okay, copy users from this, and I just need to use the IAM role. Delimiter is pipe delimiter is utilized, and reason is AWS reason. If you don't want to use reason, you can remove the reason and the command will be executed. There will not be an issue, but you just need to change these particular things. S3, so we are having all users pipe, that is a file. Okay, inside the S3 bucket, let me show you. I have copied these particular files inside the S3 bucket, and what I can have console, and I just want to go on S3. S3, and inside S3, inside the boost analytics, I have created one folder, that is ticket, and inside the ticket, what I'm having this all users pipe. All users pipe. Let me copy all users pipe path, and I'm just going to mention it over here, all users pipe.txt. Perfect. So copy users from this and IAM role. Now, how to select this particular IAM role? So Redshift, so over here, with inside the properties only, you will be having the Redshift IAM role. So what you need to do, you just need to click onto the IAM role, and you need to copy the ARN. So ARN, what you are able to see, you just need to copy this particular ARN, and this particular ARN you need to place it over here at, in place of default. Okay, so copy this from S3, and IAM role is this, delimiter is pipe delimiter, and region is this. Let me remove region at this moment. I don't want to go with region. In the next command, we will try to have the region. Let me copy this and paste it inside the database, inside the editor. Perfect. So Okay, so it has been executed. So the query is completed, and let me try to select certain records from user. Select star from users limit 10. Okay, I just want to have top 10 records from this particular table. What I have created. Okay, so what is happening over here? Like I'm having I'm able to read the data. Okay, I'm able to read the data from this particular table. Now, what is happening over here? What is happening over here? I was having certain data inside S3. Okay, and now what I have done, I have created a table in Redshift. Okay, and in Redshift, create table in Redshift and then moved the data from S3 to Redshift and then curate that data. That's what we have done. So in short, what I can say, we have gone through with 4 steps. Initially, we have loaded the data inside the S3. Then we have created a table in Redshift, and in that particular table, we have moved the data from S3 to Redshift, and then we have curated that particular data. So what is happening? In exactly, we are moving the data from S3 bucket, S3 from S3 bucket to this Redshift cluster. This is a service, and this is another service from the AWS side or Amazon side. So from S3 bucket, I'm moving the data inside Redshift cluster. So I'm copying the data. Copy. You just need to read this particular command in this particular way. Copy the data from S3 bucket to users table. Using these particular IAM role having this particular delimiter. Let me read it once again. Copy the data from S3 bucket to users table using these particular IAM roles with delimiter pipe. So you can read in this particular way for the proper understanding. So that is fine. We are able to load the data from S3 bucket to Redshift cluster, and we are able to perform the queries. That is perfectly fine. Things are like moving in a good direction. Okay, now what is the next thing that we are going to see, like how to load the data by mentioning the region. Okay, so this is the table, another table what we have created. Okay, first one is the users. Inside the users table we are able to push data from S3 to Redshift cluster. Venue is the next table what we are having, and now we are trying to load the data in venue table by mentioning the region. Okay, so the syntax for this what we are having, so this is venue pipe. This is the syntax. Let me copy this particular syntax over here. Okay, loading data in venue table. What we have created. Okay, so I just need to change the path. So I just need to provide these particular details. Uh, venue pipe.txt, that is perfectly fine. in place of IAM role, I just need to put the IAM role. And delimiter is tab over here as well. Region is AWS region. I just need to mention the region. So over here, I will be able to see the region information. So N Virginia, and with respect to the N Virginia, the region is US East, US hyphen East hyphen one. Let me mention that particular region over here. US hyphen East hyphen 1. That is the region. So I have mentioned the region. In the previous command, I have not mentioned the region. But at this moment, I'm trying to mention the region. Okay, let me copy this and paste it inside the query editor. Okay, perfectly fine. So how we are going to read? Copy the data from S3 bucket to venue table using this particular IAM role having this particular delimiter in this particular region. Okay, let me run this. Syntax addition. What is happening over here? Reason, that is fine. Okay, I have removed that particular semicolon. No? Okay, now it is working, and I'm able to get the record. Select star from venue, limit 10. So probably this particular table will display top 10 records the from we will be getting top 10 records. So we are able to get the top 10 records. So don't know like why this it is not taking comma. It is having certain issues with comma. Okay, so we are able to load the records or data from S3 bucket to this particular table, and uh, we are able to scan those particular records as well from that particular table. Just have a look onto this and ask if you are having any doubt so far. All of you, Naresh, Rohit, Swati, Vandana, any doubts so far? Anything that you are not able to get?
Ashok, can you please repeat how you uploaded data in S3?
Data uploading in S3.
Yes. So that is simple that we are just importing and giving path that text file, right?
That is quite simple. Let me show you. Okay, so we are having this S3 bucket. Mm, let me go inside the services and then S3. Okay, you just need to create a folder. So this is the view of S3 bucket. Okay, I'm having this particular bucket boost analytics 2. Okay, in this particular S3 bucket, let me create a folder, create folder, and say test db. Yeah. I'm going to create say a folder with the name test db and then create it. Create folder. The folder is created, test db. Now what I need to do, I just need to upload the data. So I'm having the files available in my local machine. I just need to add those particular files, upload them files and select all the files and then upload. Okay, so these particular files will be in the bucket, what I'm having. Okay, just have a look. So uploading is going on. It will be uploaded inside the S3 bucket. Right? It's quite simple.
Okay, so in this you have multiple files uploaded, means for five or six files have there. So when we are going to
All the
connect
files you can
in
upload in one
S3,
go.
yeah, files are uploading multiple. So when this is connected with Redshift, so we are giving this folder path only. Then all the files
Yes,
will be
yes.
imported in Redshift.
No, we are mentioning the file name. Okay, only that particular file will be loaded in this particular table. So all users pipe is a file which we are going to load in users table. All pipe venue pipe.txt is a file which is with respect to the venue table what we have created. The data what we are having in these particular files, based upon the data we have created, we have defined the schema. Okay, that's why I have shown you the structure. Let me open,
No, but input files are
say
in multiple files, means if data is in all the files, then
we are mentioning specific file path. It is not like we are mentioning the directory. This is
no, no, it is
the
taking only
bucket.
one file.
Yes, we are mentioning one file only.
If I want to put multiple files, then if my data is in two text files.
So the schema must your schema that need to be remain same with respect to this particular table.
Okay, yeah. So if my data, like I have Vinu pipe 1 and Vinu pipe 2,
Hmm.
in
So
that case,
at that moment you just need to mention the path, this one only, and then the schema for all the files must remain same for venue. Try to recall what is happening inside Spark. Inside Spark, what we are doing, we are mentioning we are having two choices. Either mention file absolute path. So based upon that, it is going to load, it is going to create the data frame. Second, like provide the folder path.
right, folder path
So
again.
folder path, what is happening? Say if we are having 100 files, so 100 files with respect to all the 100 files, one data frame will be created. Okay, and that will refer the schema with respect to the files which is available inside this particular folder. Right? If there is mismatch in certain file, then that particular file will not be considered.
Right.
It will probably throw certain errors. Okay, so We are mentioning the absolute path over here. That's why it is picking that particular file only in order to define. So we have loaded it. Now, if you want, uh, we can delete it as well. If you want to drop it over here, so booster analytics and what we are having, I can say delete it, test db, and it is asking either I'm going to delete it permanently or not. And that particular test DB will be deleted. I don't want to fail to delete what is happening. No, it has deleted it. So successfully deleted. Now test DB will be gone. We are having ticket it only. Okay, so this is the simple way, like in order to upload the files onto S3 bucket, and those particular files will be utilized in order to create the tables. And these particular files, which the data which is available in these particular files, we have defined the schema with respect to that particular data. Just have a look. So all users pipe. So, or let me show the category. Category is the small file what we are having. Okay, so inside the category file, uh, just refer the schema. Okay. Uh, mm, okay. So the schema which we are going to define over here, that is based upon the data what we are having in these particular files. So say category table that is having four columns: category ID, cat group, cat name, cat DESC. And just have a look over here. Cat id, that is cat id. Okay, cat group sports concert, then cat name, category name, mlb, nhl, nfl, nba. Okay, and then cat description, what I can say: major league football, national hockey league, national football league. So that is the description about the category. So we have created this particular schema based upon the content which is available in this particular file. And this is tab separated file. Okay, and based upon that only, like we are going to load the data. Okay, so category, just have a look onto the category. So category, I'm just picking the category table, and with respect to the category table, what we are having, the category table information is available in S3 in this particular table. S3 bucket. Okay, so inside this over here, the category table, category pipe. This is the data which we are having inside the category pipe. I just need to copy this particular URL, and I'm going to paste this particular URL over here, category pipe.txt. Okay, category pipe.txt. Then I'm going to change the IAM role. Okay, these particular two lines will remain same over here as well. Okay, so do you just need to read in this particular way, like copy from uh, this particular bucket into category table, which using this particular IAM role, having tab delimiter, pipe delimiter in this particular region. Let me copy this and paste it inside the editor. Okay, So editor, let me paste it inside the editor and do the execution. Okay, so the execution has been done, and now if you want, we will be able to query in this particular table. Select star from category and say limit 10. And that is perfectly fine. We will be able to get 10 records from this particular table. Okay, perfectly fine. Now we are able to get the same records. Okay, now what has happened over here? We have moved the data from S3 to Redshift in order to like query that particular data. What is happening over here? We are moving the data from S3 to Redshift cluster in order to query. Okay, we are moving the data inside Redshift cluster. But is there any way? Let me write down over here. So far, we have moved the data from S3 to Redshift cluster. But is there any way where there is no movement of data from S3 and we will be able to query that data? Okay, so we are looking for a way so that there will not be any movement from S3 to Redshift and we will be able to query. So in yesterday's session, what we have seen Redshift data warehouse is one stuff, S3 data lake is one stuff. These are two services. So if we want to query the data, we need to move from S3 to Redshift and then we will be able to query. But what we are having another component that is available onto top of Redshift only, that is known as Redshift cluster or Redshift spectrum. And Redshift spectrum is saying what, like there is no need to move data from S3 to Redshift in order to query that particular data. Guys, try to recall once we have gone through with Hive, how many types of tables are available in Hive? Types of tables in Hive. Swati, Rohit, types of tables in Hive.
Internal and managed external table.
Internal and managed, huh? I think you have
Internal
mentioned
and
the
yeah, same. So managed table and internal that is and external table.
and what are any other? Managed and internal both are the same thing, huh?
Same, yes. Another is external table.
External tables. And what exactly is happening inside the external tables?
External table is database is stored in any external storage like S3 or something else. Apart from the Hive means external resources.
And what is the benefit of external tables?
In this, we cannot directly delete means this will secure our data. We cannot delete this data because it's not in locally available. It's external save.
Mm-hmm. Swati, what is the benefit of external tables? Swati, are you there?
Swati is here. Huh? Okay, so let me try to
Yes,
explain. Huh?
sir. My internet connection was not there. Got
Mhm.
disconnected for a while. You were
Okay, not
asking
an issue.
something?
Huh?
What is the data from
So
Redshift?
I was asking about types of tables. Huh? So we are having internal tables and external tables. Huh? So what is the benefit
Of
of
how?
external table? You can like.
External. So
What is the
basically, the
benefit of?
external tables are having a quality like if we are deleting a external table, then the metadata related to the data related to the metadata will not get deleted once we are deleting the table. So that is the benefit of external table. Like if we want to retrieve the data after deletion of the table also, then we can just go for searching the path at metadata store, and we will be able to get the data at that particular location. That is the benefit of external table.
Metadata. So if external tables, you are deleting delete tables. Delete tables. What will happen to metadata and actual data? Okay. So metadata will be deleted or not?
No, sir, metadata will not be deleted.
Okay. And if actual data is deleted, then what you will do with metadata?
So metadata will reside in your memory, and it will have the information where the data is stored.
You are you're explaining in explaining like the stuff with respect to actual data is like actual data will remain and the metadata will be deleted. That will be the correct one. Try to think and then explain it. What about you, Rohit? If you delete external table, what will happen with metadata and what will happen with actual data?
Metadata will be deleted, but actual data will not delete.
Remain. So, Swati, what will happen? This is to each and everyone. Okay. So we are having two types of table, like internal tables, and these particular tables also known as managed table. Managed table. Okay. So the benefit of this is deleted, deleted.
And both will be
So,
deleted.
Swati, you were explaining like the opposite stuff. Okay, metadata. Once we are having managed table or internal table, so if you are going to delete a particular table, then what will happen? The metadata that will be deleted and the actual data will also be deleted. Now, let me try to show you over here as well. Okay. So, what we are having, Swati, are you able to recall? First, you need to tell me that. Are you able to recall?
Yes, sir, yes, sir.
Okay. So, just have a
Like in
look. So,
external
this is the
table,
category.
actual data will not, the data resides.
Hmm.
But if we go for searching the table in the database, we will not be able to find that table.
Okay. So, drop table, and this is a table what we are having over here, and let me try to drop this particular table. Okay, so what will happen, the table will be dropped. Okay, and what we can say at this moment, select star from category, and limit 10. So we will not get anything. Okay, we will not get anything because the table has been deleted. The table has been dropped. So error category does not exist. So this table does not exist. Now this is the managed table, and what we are having, we have copied the data in this particular table from S3 bucket. So whatever data was available over here, that has been deleted. Whatever the data which we are having in this particular cluster, that was deleted. Now once we are having the external table, external table over here, inside the external table, what we are going to do, we are going to create the table, we are going to create external table in Redshift only. Okay, so at that moment, once you are going to delete the table, okay, the metadata that will be deleted and the actual data will remain on S3 location. Now, because we are going to refer the S3 locations in order to query that particular data. And try to recall, Rohit and Swati, probably you will get this. Once we were going through with Hive. So in Hive, what was happening? uh, we were having HDFS as a location. HDFS as a location where we are storing the data. Okay, inside HDFS, that is the storage layer. Storage layer. Okay, so HDFS was the storage layer, and MySQL, that was metadata, metastore. Metastore that was used in order to maintain the metadata. Now, once you are going to run the drop table command, then the metadata which is available inside the inside this particular location, MySQL metastore, that will be dropped, and the SDFS, there will not be any impact onto the SDFS because we are referring the location. It is not going to delete the data from that particular location, and that is the beauty. Okay, if you are having actual data, then just going through with that particular data, you will be able to write down the schema. Okay, say one Toyota bridge view IL, okay, 0. So we are having this particular data, and just going through with this particular data, you can write down the schema. Okay, but if you are not having the data, what you will do with schema, right? Swati and Rohit.
Yes, sir.
Yeah.
Okay, and two others as well, Vandana, Naresh. Okay, is it clear? Vandana, Naresh,
Yes, sir.
Naresh.
Yes, yes, sir. Got little bit.
Okay, so so external tables are having the beauty, if you are going to run the drop table command. Okay, drop table command. Let me drop table. Drop table command. So the metadata will be deleted, but the actual data will not be impacted. It will remain same over there, and if required, we just like refer that particular data, and we will be able to create the table. And that's why, like, it is preferred to create external tables. Like external tables, these are the most preferred tables in during inside the production environment, because we don't want to like if like by mistakenly someone has executed a particular drop table command, then like Okay, the metadata might be gone, but the actual data will not have any impact. Data, that is very precious stuff. However, like metadata is also costly for us, but we can't compromise actual data with metadata, right? So external tables are are good uh, for the production environment where actual data will remain same. Now, same stuff we are going to replicate it over here inside the Redshift. So whatever we have seen so far, that is with respect to the internal table or managed table. Okay, if you are going to run the delete table command, then things will be gone because you have moved the data inside the Redshift cluster. You have moved the data inside the Redshift cluster, and if the drop table command is fired, then that particular table will not be existing in the Redshift cluster. Okay, now external tables over here, what we are going to do, we are going to to
So
create the
one
external
query,
table. Mm-hmm.
like we are creating an external table now.
Mm-hmm.
Is it happening like the view over that table has to be external? Like we can define, okay, this is external view. View for view, there is no concept of external, right?
No, there is no concept of external or internal on view.
Okay, okay. Thank you, sir.
Okay, so what is happening over here? So I'm going to copy something now. So there are two things what we are going to see once we are talking about uh, so once we are going to create external table, so inside the Redshift there is one entity added that is known as uh, schema. Okay, so what is happening in normal databases or traditional databases? We are having database. Okay, in database we are going to create different database, and database are having tables. What I can say, database service, not service, or DB. I can say inside DB we are having databases, and databases are having tables. Okay, so say we are having MySQL DB. Okay, my inside MySQL DB we are having different databases, and different databases are having like database is having then tables. In the yesterday's session we have seen so this is nothing but MySQL. Okay, MySQL is a database what we are having, and inside MySQL database we are having multiple databases with respect to our services or the task what we are going to perform. So databases. Okay, so daba databases. Okay, so inside this MySQL, we are having these particular database, say information schema. Okay, just we have discussed about the meta store. It is going to handle all the schema from the Hive. MySQL is a database, NAV is database, a Sentry, okay, test, big data factory. So over here these are the databases, and inside the databases they use big data factory. Yeah. Okay, so we have used big data factory and show tables. Inside this, what we are having tables. So employee table, single table is available over here. That's what I mentioned over here. So inside the normal databases, what we are having database is having further databases with respect to like our task. We are going to create multiple databases. You can think in this particular way, like this is my Windows machine. Windows machine is having different disk, and disk I'm having folders, and folders are having files. So that is the stuff like what I'm having. But inside the Redshift, what we are having uh, another entity that is added over here. So Redshift, Redshift. So inside the Redshift, we are having databases, and databases is are having schema. Okay, and schema will have tables. Okay, a little bit you can say more one more entity is there that is going to define the structure how the tables are being created inside the Redshift. Schema is the entity, and how we are going to why we are having schema over here, that is with respect to the task specific only. Yeah, another entity has been added. Say it is going to like provide you more details with respect to the task that you are going to perform. So schema is another stuff that is added over here, in like you are going to create a schema, and in schema you are going to create different tables. So for this, the steps in order to like work with a spectrum, so we can say over here what we are going to do, once we are talking about external tables in Redshift, we are going to learn about the the schema definition and all. That is the first step. Second thing, we are going to learn about the Redshift spectrum as well. Redshift spectrum. Okay, external tables means we are not loading the data inside the Redshift cluster. We are utilizing Redshift spectrum in order to read the data directly from the location, and then we will be trying to query. Yeah. So these things will go in a parallel way, like we are going to learn Redshift spectrum, we are going to read the we are going to uh, discuss about the action table concepts in Redshift, and like what is the beauty of schema that we are having in terms of a new entity in Redshift data warehouse. So the external tables, in order to deal with external tables, step number one that we are going to have, step one, we are going to create a schema. Why? Because like inside the Redshift we need to have a proper schema over here. Inside the previous command, just have a look over here. So once you have dropped this particular table, let me try to drop this venue table. Okay, this is the venue table, and I'm trying to drop this particular table. Okay, this is the query drop table dev. This is the database. Select database. This is the dev. Dev is the database. And what is public over here? Public is the schema. Just have a look. Select schema, that is public. So public is schema over here dot venue. So this is the way how tables are being described in the world of Redshift. Database, then schema, then venue, and this is like a mechanism in order to refer a particular table inside Redshift. So schema is mandatory. Schema we just need to define a particular schema, and then we will be able to have it. So we are going to create a particular schema. So create schema, create external schema. So we are not moving with the public schema. We are creating an external schema. We can give a name over here. It will depends on you, the name what you are going to mention. Say I'm mentioning, say, spectrum schema from data catalog. Okay, data catalog, try to recall the glue. Over there we are having the data catalog. Database, you can create your spectrum database, say new DB, or what I can say, spectrum DB. Yeah? Spectrum DB. Okay. And IAM role, you just need to mention the IAM role over here. Okay. IAM role, and IAM role, let me mention the IAM role over here. This is the IAM role. Okay, IAM role, and create external database if not exist. So it is going to create the external database if not exist. So what we are having, it is going to create where inside the data catalog. Okay, so just have a look over here. We are going to create a schema. Let me try to copy and paste it inside the query editor. Okay, so we are going to create the spectrum schema. Okay, spectrum schema. Mhm. Okay, so the spectrum schema has been created. Now just have a look over here. You will be able to see spectrum schema. Okay, so spectrum schema is available over here. So just we have created a schema over here, and this is the like straightforward syntax in order to create the spectrum schema. Now step number 2, what it is saying, you just need to create the table. Okay, so step number 2, create the table. Create the external table. External table. Okay, so what we are going to do, we are going to copy the command in order to create a table. Previously we were creating the internal tables. At this moment what we are going to do, we are going to create external table. Let me copy this command, create table user. I'm just going to copy this particular schema. Okay, now this is the syntax, like create table, and probably like you are able to recall, row format delimited, fields terminated by this, location is this one. Swati, Rohit, in Hive we have seen.
Yes,
Okay, so what we are going to do, create external tables instead of internal. So create external tables, spectrum users. Uh, spectrum schema dot users, and users 2, I can say users 2. This is the table what I'm going to create at this moment, and row format delimited and fields terminated by this. So row format, I'm going to create external table row format delimited, and what is the delimiter over here inside this? Delimiter is pipe delimiter, huh? So I'm going to use the same delimiter over here, pipe delimiter. Okay, location s3, so I just need to give the location s3 bucket and venue pipe, copy s3 all users pipe. I just need to mention this particular location. Perfectly fine. So I am going to create users two table, that will be the external table with this particular schema. Let me try to remove these particular things. Okay, user id integer, username is this one. Okay, this is the schema for this particular table. Let me remove this semicolon as well. Okay, row format delimited, fields terminated by this, location is this one. Okay, so what is happening over here? I'm going to create a external table based upon what? Based upon this particular data. Okay, this is the location of the data what we are having, and on top of this particular data, this particular table will be created. And this particular table is going to use what? This spectrum schema. Okay, in spectrum schema, this particular table will be available. Okay, so just let me copy this particular command and
So
paste
is
it
there a
inside.
fix that every time when we are creating this table, so this spectrum schema dot file table name. So this is the format protection to
If
fix XML table.
if you are having any another schema, if you have created any another schema, then you can mention that particular schema. With respect to the use cases, say like we are having two teams. One is R&D, second one is say engineering team. So say for engineering team, all the users are having engineers uh, engineer schema, and for R&D they are having the R&D schema, that is denoting like different departments with respect to each and every team, and based upon that like we are having different tables and all. So what I can say, a little bit more description or entities has been added for the reference perspective only, and that is the way how to refer particular table in Redshift, right? So that particular schema must be created where you are going to create the table, right, Rohit?
Yes.
Okay, so over here, okay, so the schema has been created, and now what I'm going to do, I'm going to use that particular spectrum schema in this particular table that is going to use this particular location. Let me do the execution, and inside the spectrum schema I will be having that table, if expected character, pipe txt,
Semicolon in the end.
okay, let me remove. It is throwing error with semicolon. Sometimes it's taking semicolon. Okay, so we just need to check for the spectrum schema, and inside spectrum schema what we are having users too. And
Redshift.
yes, so that table has been created. And preview data, what is available in this particular table? So preview data, it is going to fetch that particular data from S3 bucket. Users spectrum underscore schema dot users to it is not listing the records. Let me create a small table. We can create a small table. Let me create a category table. And we just need to replace this particular command, say spectrum users, instead of this create external table category 1. Okay, and let me remove these particular things are not required. Small integer, remove column. Okay, so format delimited, and I just need to use the category path. Category, copy, location S3. Okay, category 1 field terminated by pipe. So category 1 is having pipe. uh, hmm, I'm looking for the delimiter. Pipe category is having pipe delimiter. Perfectly fine. So let me do the execution. And inside the spectrum, what we are able to get, users 2 or category 1 as well. And category 1 preview data is not providing you the preview. And then error ಆಗ್ಬೇಡ. Category 1 limit category, and it will be mentioned in this particular way. Spectrum schema dot category. Mhm. Sports MLB Major League Baseball. It is reading the data from this particular location. Like one, just have a look over here. We are able to get, but it is not listing it properly. Okay.
So is it giving error that it's not a valid JSON? So it can read any of the format or only particular JSON.
I think let me try to let me create a sample data. Hmm. 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 Actually, when I'm practicing this, at that moment it was also throwing this particular error. So what I can do, probably I can proceed with different data set. That will work out, not work out. Hmm. Hmm. Okay, so let me upload this particular file. Rating. Upload. So I'm going to upload a new file, that is a data file. That will take time. It's very big file. Okay, so what I can do, orders. Let me try to orders new. dataset. Okay, orders new. I want to upload it over here. That is the small file, and we are going to define what we are going to do. We are going to define a schema onto top of that particular file, and then we are trying to read the data. Okay, add file, orders new, orders new, upload. Okay, so with respect to the orders file, just have a look onto the schema. So what we are going to do, we are going to create an external table, that is, that will be the orders table. Okay, say I'm going to create an external table. So create external tables, order, orders. Okay, and this particular table, what we are having, that is order ID is a say small integer. Then what we are having, order data. So we are going to pass it inside the varchar. Then then order customer ID. That is also a small integer. Order status. And that is of say varchar type. Varchar type, row format delimited, and that is a CSV file. So delimiter will be comma over here, and the path what we are going to have, that will be this particular path. Let me copy this particular path. So copy URL, and I'm going to paste it over here. Okay, so this is the path. Perfectly fine now. So we are going to create an external table, orders, and that is going to utilize the spectrum schema, order ID small integer. So this is row format limited. Okay, things are looking fine. Now let me copy and paste it. Okay. So we are going to create an external table. Okay, and that is the orders table. Hmm. Okay, so we are going to create the tables, orders table. So the table has been created. Now what we are going to do, we are going to say read the certain records. Now select star from this particular table, limit 10. Okay, so we are trying to read the data from that particular table. So it is showing the records, but with certain errors. Past manifest not valid object. Just a minute. Bad master. Just a minute. I'm getting this particular error from the morning itself. Hmm, 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 hmm. This is certain parser related issues. Hmm. Okay, so I will check about this particular error. This is like probably because of certain property or certain parser related stuff. It is not a bigger issue. I just need to check it. In the morning itself, I was getting this particular error. So uh, I will check this particular error and I will inform you. Okay, but the main thing is that we are able to like create the tables and all. And in morning, what was happening? I was able to get the details from particular table. I was get a view of the data. So schema, that is the schema that we have defined. Okay, and oh, preview data. So preview data is not happening. Check this particular error. If you are having any issue or anything that you're not able to get, you can ask. Apart from this, like you can ask anything. We are not able to get the outcome over here. That I need to check probably like with the help with glue. It is having certain issues. It is not able to get the data from there. Spectrum data. Yeah. Apart from this, is there any issue? Swati, Rohit, Vandana, Naresh, anything that you are not able to get? Huh? Hmm? Tell me, huh? Any issue, friends? Anything that you are not able to get?
No, sir. No, sir.
Mm-hmm. Vandana, Vandana, anything that you are not able to get?
Sir, I still need to practice, so I'm not able to say anything right now.
Until unless you are not going through with these particular details and not practicing on AWS environment, you will not be get anything. Huh? At this moment you will feel that I know this is the simple stuff, but once it is the time to do it by yourself, then you will stuck, definitely you will stuck, huh? Okay, so Swati, can you explain what we have covered in today's session? Hmm? Swati or Rohit, anybody?
Yeah, Ashok, just I want to just means confirm. So major difference in Redshift and Redshift Spectrum is that only the file transfer system means in Redshift we need to transfer data from S3 to Redshift server, correct? Redshift cluster. And in Spectrum we are not
Hmm.
transferring. Yeah, and also the creation of table. In Redshift, we are creating normal table, and in Redshift Spectrum, we are creating external table.
Hmm.
So this is the major thing. And other than that, when you created that external table, so it is directly linked with S3, and whenever we are querying, so it is giving output directly from S3, right? That we
Hmm.
facing the error, so it will show us the directly data from that one.
Hmm.
Okay.
Okay, and just have a look, like these particular tables we have created now. So inside the database, what we are able to see, we are having the spectrum DB and spectrum DB1, what we have defined. Okay, so today itself we have created these particular databases. Inside these particular databases, just have a look, like category one, orders, okay, users two. These are the tables what we have created. Now, like if we are going to click onto the category, okay, so just have a look onto the input format. So we are having certain format related stuff, format related error. So that or certain issue with respect to the communication between these two services. I will check that particular stuff, and then it will be resolved. I need to check. So I will share that particular code with you all, like how to query. But the main thing is that like we are able to create the external tables, and we are able to to load the data as well. Like loading data is happening over here only. Like say location, we are just like targeting the location that this particular table is created. This is the external table, and it is going to refer this particular data. Okay, so over here loading it is loading, like we are not loading it inside the Redshift cluster, but we are referring this particular data or this particular location, and now we will be able to query onto this particular data. Okay, so Redshift Spectrum, there is no movement of records. Inside the Redshift warehouse, there is movement of records. We are copying the data from S3 to our Redshift cluster, and then things are happening over there. If we are going to drop the tables at that moment, then the metadata and data that will be deleted. And over here, if we are going to drop the tables, just have a look over here. If I'm going to, this is the metadata which is maintained over here. If I'm going to drop the table inside the glue catalog, I have mentioned the data catalog over here. Once we are creating this particular schema, okay, that is the step one. Create external schema, spectrum schema from data catalog. So data catalog, where we are able to see that data catalog. So inside the AWS glue, but we are having data catalog. Data catalog is having databases, and inside the databases what we are having spectrum db. These are the databases what we have defined now. So database name spectrum db1, IAM role is this one, create database if not exist. So this database we have created. So database one, and database one is having what? So database one is having these particular tables. Okay, these particular tables. Now what I can, let me try to do certain R&D. So we are having this particular table, say category 1, and I'm going to drop it. So let me drop this category 1. Drop. So category 1, it will be dropped from here. So spectrum schema is not having category 1. Now what I can do, I'm going to mention this particular database name instead of this. So spectrum db, this is the database, and category 1, spectrum db dot. I'm going to use this particular command in order to create category 1. Okay, so I thought there is certain issue. Let me create this particular table once again. Mhm. Cross database reference to the database spectrum db is not spotted. Mhm. Okay, leave it. I will check it. Why we are not able to get the records. But the main thing is that we just need to create the external tables. Okay, and just by creating the external tables, we will be able to refer it. The property or something else what we need to define, I will check with that. But over here, things like by visualizing these particular things, I didn't find any issue. Okay, like we are able to see the tables, we are able to get the records. Same things are reflecting inside the glue catalog as well. Okay, so if we are going to refresh, we have dropped that particular table, that entry will be dropped from here. So just have a look, category will be moved. Category table that has been gone. We have dropped that particular table, so the category table has been removed from here. Okay, I will check that particular stuff. Okay, why we are not able query, but these are the things like the location of the file is this one. If we are creating the authors table for the users table, this is the location. Okay, and these particular things must be visible over here. The query I will show you. I will check and confirm. Okay, if something is there that you want to discuss, then tell me. Anything else that you're willing me to explain? Okay, so if nothing is there, then we can conclude the session for the day. And are you practicing these particular things, Swati, Rohit, Naresh, and Vandana on your EWS environment. Are you practicing?
Yes, Ashok. Yes.
Naresh, Swati,
No, sir.
Vandana, try to practice. Try to practice, Naresh.
Okay, sir.
Okay.